Hello, this is your UGTA Bailey, and in this video I'm going to be going over the topic that was determined most confusing based on the Muddiest Points survey, the Fantastic Four method of writing recursive algorithms. As you saw in the slides, the Fantastic Four method of recursion is a method of writing recursive algorithms developed by Professor Chen, a computer science professor on the ASU Tempe campus. It attempts to break down a recursive problem into 4 steps. In theory, by following these 4 steps, by the end you should have a complete recursive algorithm. To illustrate how this method works, I'm going to walk you through one of the questions from Week 4's Unit 7 exercise shown here. We want to implement a recursive method called SUMList that returns the sum of all of the elements in a list of integers pointed to by the reference head. Note that the sum of an empty list is 0. This will be important for writing our base case. The first step is to determine the size n problem. You can think of this as the overall problem you're trying to solve. This is usually your method signature. We want to return the integer sum of the entire list pointed to by head, so we write our method signature like so: public int SUMList node head. The next step is to define our base case. This is often an if statement. The base case defines when the recursion should end, so it should not contain any recursive calls. When should our algorithm stop here? When the list is empty or there are no more nodes. So, when the recursion reaches the base case and there is no more nodes left to add, it will return 0 because we don't want to add any other integers to our sum. We can write this into our algorithm using an if statement like so. If head is null, return 0. This will return 0 and stop the recursion. The subproblem is often the most confusing part of the algorithm building process. Since we're sequentially adding values in a list, we can break the algorithm down as the head node plus the list after the head node. We're breaking the addition down into pieces as though we're adding many smaller lists to form the sum of one large list. This is similar to your maze problem in the homework, where you created many smaller submazes to build one large maze. This can be a bit confusing. The node that we pass into the recursive call is not the same head that pointed to the beginning of the list at the start of our algorithm, but the head of the sublist. So we can write this in as SUMList head.getNext. The overall solution to the problem is found by taking the subproblems and adding them all together to find the size n problem. As I said in the previous slide, the subproblem is the sum of the sublist found by adding the list without the head. We will assume that getInt returns the integer value stored in the head node. So we need to add the head to the sum of the rest of the list. We need to have faith that the answer to the subproblems will all be recursively calculated correctly. Now we have a fully built recursive algorithm. So let's look at a visual example of our newly built algorithm. The first head is the node containing 1, which is passed into the algorithm. The first sublist is 4, 7. We pass in the node containing 4 as the head and the sublist is 7. Then we pass in the node containing 7 as the head and the sublist is null. We reach our base case, which returns 0, and work our way back up the returns. 7 plus 0, then 4 plus 7, until we reach the first call and return 1 plus 11 to give us the final answer, 12. If you have any further questions, I would love to answer them on Piazza or over email, and good luck on your next exam.